So I'm already messed up once and I've had to reset. I started to say this was about fractional roots, and it's not really about fractional roots. It's about fractional exponents, which are typically normally expressed as roots. So first of all, square root of 9 we know is 3. So that one you probably already knew. Third root of 8, that's saying, hey, what times what times what? What to the third is equal to 8, and in this case we know that's going to be 2. And then fourth root of 50, I don't know. I know 2 times 2 times 2 times 2 is going to be 16, and 3 times 3 times 3 times 3 is going to be 81, so that's going to be somewhere in between there, so maybe 2.7, maybe. But this is where I'd probably definitely need a calculator to figure that out. So let's see how we do it in the calculator. And one of the interesting things about the calculator is almost all calculators have a square root button on it. So this one has a square root button right here. You have to do second and square root, and then you can do not 2, 9, and hit enter. Okay, so that's 3, and can't see it there. It's 3. Then the problem is, well, how do I do a third root? Because most calculators do not have a third root button. A student showed me the other day you can find third root. I think if you go to math, and there's a way to do that. So if you go to math, you can do it. But really related to this, it's helpful to know how to put this in the calculator using just the raised to button. So another way to express this, the 9 here, is actually 9 to the 1/2. Okay, and we live in an electronic age, and most computer programs use this to mean raised to the power of. So you do 9 and what's called the caret, C-A-R-A-T, and raise it to this thing. And the only problem, and what I usually do when I show this to students, is I have them put this in their calculator, and depending on the calculator, some of them will get 4.5 when they type this in. And the reason is the calculator does 4 divided by 1, 9 divided by 1, and then divided by 2. For many calculators, you have to put this in parentheses. It depends. The calculator I have right now doesn't require it. I'm going to try to remember to put them in just as a good practice, but it actually creates kind of a mini grouping symbol of its own. But in most calculators, you can never go wrong typing this in. You may be doing some extra ones. But so just to check that, 9 raised to the, so the caret is right here by below clear on this calculator, raised to the, and so like I said, the newer versions of these, they actually raise it up. On other versions, you'll actually see the caret, and if you see the caret, you definitely need to put the parentheses in. I'm going to go ahead and put the parentheses in and say, oh, to the 1/2. So it's 9 to the 1/2, and then I hit enter, and it's also 3. So those are equivalent. So this right here, if I put it in my calculator, is 2 to the 1/3. Definitely need to do 1/3 over here. You could have done 0.5 over here. You cannot do 0.33. You won't get exactly the right answer. So with most of our fractions, we're going to need to put them in as fractions and not as decimals, unless we know for a fact that they are exact. And to this last one, I've got a good estimate there, so I'm going to do it in my calculator again. I'm going to say 50 raised to the 1/4. And if you need to get down from up there, some people don't know how to get, if they needed to add something else, if you use the arrow key over, that brings it back down to the next line. If you happen to have a calculator that does something like this. You hit enter, and oh, it's pretty close. 2.66 is a number. I usually like students to round to the second, to the hundredths place. And okay, hopefully that's still working. Yeah, I had a pop up on my screen. All right, so that's the basic idea. If we know how to write these in the calculator, we actually know the main skill that we need to do if we're going to do this by hand, which is we need to realize that this is 9 to the 1/2, and this is 8 to the 1/3, and this is 50 to the 1/4. And I always like to tell students, I got a 3 and a 4. Where'd the 2 come from? And where the 2 came from is there is an invisible index up here. This thing up here is called the index. And because we use square root so much, we're just lazy and we don't write it. And there's nothing wrong with writing it, but you usually will not see it written. So don't let that fool you. Some people, when they see it and they don't see it there, they're like, oh, that's over 1 over 3, that's 1 over 4, and they see it without anything written there, and they think it's 1 over 1. It's not. If you're using the square root symbol, it is, there's really kind of an invisible 2 there. In the same way that there is an invisible 1 for an exponent there, and an invisible 1 for an exponent there, and an invisible 1 for an exponent there, which is actually where the 1 comes from, because we're about to change gears, and we'll need to know that. Okay, so the next slide I've got for you here. So we're going to say, okay, I've got some number. These are just placeholders for a number. How can I write that as an exponent? So first of all, we have to remember from our time before that we have an invisible exponent of 2 there. If you need to write it, write it. I just gave a quiz the other day. I saw many students who wrote it in, and they're the ones who got it right. Others did as well, but it's hard to get it wrong when you've got it written there. So this is going to be x. So here's how you think about it. You're like, well, this is x to the 3rd raised to the 1/2. It's another way to write it. Those are equivalent. If you put either one of these in their calculator, it would work. And then you're like, oh, I've got a power to a power, and this is where you need to know those rules. And if you don't know those rules, you need to back up a step and go back and learn, oh, what's the rule when I've got a number here and a number here? We multiply those, so that's 3 is like 3 over 1, so I multiply straight across. It's 3, and the 1 times the 2 is 3/2. All 3 of those are equivalent. Whatever that number is that I plug in my calculator, if I do any one of these variations, I will get the same number in my calculator. So this right here, once again, if I want to think about it this way, okay, this is x squared to the 1/7 power. And so when I multiply across, which is my power to a power rule, I get x to the 2/7. Okay? And usually after I do a couple of these, you realize, oh, I don't really need this middle step. There's a pattern here that hopefully you recognize. The next one down here, notice I've got the root on the inside. So this is x to the 1/7 on the inside, but it's squared on the outside. So once again, I'm power to a power, I multiply, I get x to the 2/7. Notice those are identical. So these two things over here, since these are equivalent, these two over here must be equivalent. So what happens is it doesn't actually matter if you take the root first or if you take the power first. Just you can't flip them around. You've got to still use them, but you can take the root first and then square it, or you can square it first and then take the 7th root. But it doesn't matter which order you do it in, because this is all really related to multiplication, and multiplication is associative and commutative. You can move things around. You can do things in different order as long as it's all multiplication. Okay, that's the basic idea. So let's look at solving or simplifying a problem using a couple of our other rules that you should know already. So I've got y squared root 3 and the 5th root of y. So I'm going to rewrite these with fractional exponents. So this is going to be y to the 2/3. I'm jumping right. I noticed that pattern. It's always going to be this on top and the index underneath, times y to the 1/5. And so this is where, once again, we need to know this rule. When I'm multiplying like bases, and it is multiplication, it's not addition. If this was addition, I couldn't add these things together. They're not like terms. But they are like bases. So 2/3 plus 1/5, got to add fractions. So I'm going to have to convert these. So this is basically 2/3. I can convert it to 15ths. Multiply times 5 over 5, I get 10/15ths. And I'm going to add, that's going to be 3/15ths. So I've got my my common denominator there, and I add them together, and it's y to the 13/15ths. And we'll usually leave it this way, even if it's like 15 over 13, because what this tells us is I raised this to the 13th power, and then I took the 15th root. And so it's nice to leave this as an improper fraction, even if the number on top is different. The next part is division. It's kind of so our rules don't change. The only thing that's different here is, I've got fractions, and fractions sometimes are harder for people. So this is going to be a to the, and this would be tempted to say 3 over 1, but it's not, because you got the little invisible index out there. So this is a to the, make sure I get it right, 3 over 2 over a to the 1. So I'm subtracting, because that's our rule for dividing like bases. So 3/2 minus 1, or 2/2. So this is going to be a to the 1/2, which I could leave that way, or based on instructions, I might change it back to that. So that's very interesting. Look what we started with and where we ended up. You know, these are equivalent. Whatever number this was, if I put this in my calculator, I should get the same number here. And this is actually a way I could check myself. Even if I'm just using abstract variables here, I could actually plug a number in here and say, hey, does this thing I started with equal this thing I ended with? And that'd be an interesting way to check myself on a test or a quiz. Okay, in the home stretch here. So now